Hello everyone and welcome to the second video of our Java programming lesson. In this video we're going to talk about program development in Java. If you have not watched the previous episode, click the link in the description or check out this card. Now without further ado, at first, roll the intro. Alright guys, so like we talked before, we're going to learn about program development in Java. So the mechanics of developing a program include several activities: writing the program in a specific programming language such as Java, translating the program in a form that computer can execute, investigating and fixing various types of errors that can occur. Software tools can be used to help with all of this process. So basically the first point, which is writing the program in a specific programming language, in this case we're using Java of course, and translating the program into a form that computer can execute. This means that we have to convert our existing program into a form that the computer can understand, because the computer cannot actually understand our human language like the way I'm speaking to you. If you say to the computer, do this, it can't do that because it doesn't understand that. What computer understand is basic binary language, and the compiler is a program that compiles or translates our existing programming codes into a form that the computer understands. Next up, we have language levels. So there are 4 programming language levels: machine language, assembly language, high-level language, and 4th generation language. Each type of CPU has its own specific machine language. The other levels were created to make it easier for human beings to read and write programs. Like I discussed before, each type of CPU executes only a particular machine language. A program must be translated into machine language before it can be executed. A compiler is a software tool which translates source code into specific target language. Often that target language is the machine language for a particular CPU type. Although the Java approach is somewhat different. For Java, the Java compiler translates Java source code into a special representative called bytecode. Java bytecode is not the machine language for any traditional CPU. Another software tool called an interpreter usually translates bytecode into machine language and executes it. Therefore, the Java compiler is not tied to any particular machine. Java is considered to be architecture neutral. This next image actually describes what I just said. So in the image we can see Java source code is being converted to Java bytecode by the Java compiler, and the Java bytecode is being changed or translated into machine code by bytecode interpreter and bytecode compiler. A much more simpler and easy example can be this, is that for other languages, say for example C, C++, Python, if you compile a program in those languages, then these programs run on those specific architecture machines. For example, if you write a C or C++ or Python or any other language code in Windows, then whatever program you just compiled, it will only run on Windows on that specific architecture. Again, if you run that same code in Linux, it's going to run only on Linux. If you copy the compiled program from Linux to Windows or Windows to Linux, it is not going to run. On the other hand, in case of Java, you can run Java code across all platforms. That's why we call it's a cross-platform language. There are many programs that support the development of Java software, including this list, but for our programming course we're going to use Eclipse. Some extra knowledge about syntax and semantics. The syntax rules of a language define how we can put together symbols, reserved words, and identifiers to make a valid program. The semantics of a program statement define what that statement means, its purpose or role in a program. A program that is syntactically correct is not necessarily logically, semantically correct. A program will always do what we tell it to do, not what we meant to tell it to do. Next up, we have errors. A program can have 3 types of errors. The compiler will find syntax errors and other basic problems. which we call compile time errors. If compile time errors exist, an executable version of the program will not be created. A problem can occur during program execution, such as trying to divide by 0, which causes a program to terminate abnormally. These are what we call runtime errors. And third, a program may run but produce incorrect results, perhaps using an incorrect formula. We call them logical errors. In short, basic program development is as follows. In this flowchart, we can see we edit and save a program, then it reaches to the step where we compile the program. If it finds the errors, it stops, but if it does not find the error, it executes program and evaluates the results. That's all for this lesson. In the next lesson, we're going to learn about object-oriented programming. Till then,